Alright guys, let's finish this sucker up. So what we're gonna do in color, we're gonna create I'm gonna look at my old code just because just because so do I want to? I don't think I want to do it like that. That is an interesting way to do it. But that's not what we're gonna do. We're going to do a red color, an orange, red, an orange. We're gonna create a rainbow. Green, yellow, green, cayenne, deep blue, bright blue, and then dark blue. And we're going to use just some tuples. So we're going to do 1, 15, 30, 45. We're going to try to keep these all around the same gradient as well. So this will be 60, 30. Um, 90, 20. So we're going to try to keep a smooth gradient. 90, 115, 30. 60, 115, 30. And this might be boring to some of y'all. Some of y'all might want to skip ahead. 30, 90, 30, 90, 115. And you guys can probably figure out where we're going with this. And you could do this a bunch of different ways. There's a bunch of different ways to do this. I feel like I skipped a color. 30. 115. Excuse me. There's our yellow. There's our green yellow. 30, 90, 115, 30, 60, 115, 45. And here we'll go 30 and then 45. Add a little more blue into this, so a little smoother transition. We'll kind of taper off that green, the red out of the green as well. this would actually be more of the bright blue and the deep blue. And these aren't exactly dark colors, but they're average, mediocre. So our general lerp function is going to... Do we want to use a lambda? I mean, we could. I don't know how I feel about that. I think I'll do A, B, and T. And then we will return like that. I prefer just to directly index. There's no need in having over fancy code sometimes. And then we will take a distance and a max distance. I don't know if I even want to do it like that. I don't think there's... We might as well just pass it here. I don't know what I'm doing. But we're gonna say that... What an interesting way to do that. You know what? We will try Copilot's way. This isn't what I intended, but I've seen this done before. I don't think this is gonna work, because this is taking a T Oh, it's taking the length of this. Okay, length minus 1. So it's trying to scale this to the length of this and get that color. That's not the worst way to do this. as long as this doesn't end up as a -1. I can see some problems with this also. But we can try it. Why not? Why the heck not? So in our path, we import color and interpolate colors. And then when we we need to determine a max distance. And so to do this, we're going to define a what is it called? A Manhattan distance. And actually, we don't have to do that. How do we want to do this? Yeah, let's do that. Let's define the Manhattan distance. And it's not the same equation. That's not right. It's the... Oh, that actually is the Manhattan distance. I did this backwards earlier. I bet some of y'all are... This is actually wrong, so no wonder my equation was wrong, because I was having those bugs, and I was thinking like this didn't seem right, so that's why this makes more sense, that we're subtracting x and subtracting y and adding those values together. That's a straight line distance. But on a grid where the a squared plus b squared gives you c squared is the straight line distance. I feel dumb. I can't believe I even did that and said that, but whatever. So we should be able to update our map integrity function, or determine threshold where we don't have to offset anymore. And I think while we're at this, reset mapping squares, we are going to set the color to interpolate the colors. And we're going to take the square's distance, and then we're going to do max distance. And I'm only doing this for readability. And then the current distance, threshold distance, and max distance would be the Manhattan distance of the map squares. But the problem is a map can circle back around. So we're just gonna double this number. So we'll almost never reach the end of our color gradient. Maybe we'll scale that to like 1.5. Let's just go ahead and do 2. Keep it simple for now. And there is our color gradient. Now we can't see where the green is, so let's try. If we do this, I feel like we're gonna hit index out of bounds. That does get us to the blue. The problem is we can barely see these. So what if we swap our start and end colors? Oh, you guys can't see this, I forget. And so now we have our color gradient. We have these dynamic maps. And this is not just the color gradient, this is actually the distance away from the start point. So, the only thing I'm worried about, we need to run a few iterations of this. Look on the screen, because I'll probably... I know I've got this here twice. Let's hide this for now. That way this opens on the correct screen. And so yeah, now you can see that our new threshold distance with the correct equation is actually at a reasonable number. And we can actually I should add comments on all of this, but what am I looking for? Oh, I want to put this as an int, just to kind of clean up. But yeah, let's do a few of these checks. So that looks pretty good. And then if we generate more start points, we end up with all these little red dots, and each one of these should find a path. And we will get to that next. But I want to do a few more of these checks because I don't want to stop and trace down some bugs. I have a feeling that if we end up having to go around the map, that we're going to end up going beyond our index. Which most of our maps seem to look really good. These color gradients. Okay, so we're in a dead end. We hit the dead end. So we hit this check. We froze. The only problem is it never popped off. So we did hit the we are in a dead end check. We need to, when we hit a dead end, we need to reset mapping squares. That's something that we're not doing. So that was one of those cases where we were not able to get out. We did hit our endpoint check though, so that's good. So part of our logic was right. These color gradients look really good. I wouldn't mind making the blue a little more dominant in the yellowish areas. Like if we moved all of these up one. Yeah, see, this one should be a little bit farther away. And that looks a little bit better. I really love how you can tell that this spot is farther away than that, or this is farther away than that. It's a very cool algorithm when you see it visualized. So that one gives us a very full gradient. I don't know if we will go beyond our bounds with the way that we're generating this map. I know we keep doing the same thing over and over again, but I mean, I could turn the sliders back on and create a little bit more interactive UI, and that's something maybe some of you might want to do. Generate these maps and do these calculations without restarting. List index out of range, that's what I suspected. So what we'll do, and I don't know why I didn't just do this before, in the color for a T, we will do the minimum of the distance or 1. We'll never go over. And that should fix that problem. So the next thing that we're gonna do is that find the exit. So we'll come back to this. I think we've done this. I'm gonna rename that to collapse endpoint region. So find exit. How do we find our exit? So now we start at Pathfinding functions. These are the same thing. Excuse me. So this is our main entry point. I can collapse all of these now. So to find an exit, we're gonna do something similar, I believe. And we're gonna do mapping squares. We're just gonna say step. So if we are walking, we will hit this, and then if self dot step equals none, we will say that the self dot step equals self dot start position, start location, and then step equals self dot find next step, and then let's do that first. Find next step. So we're gonna say that the fastest route equals none, and then check adjacent squares. So if it's mapped, we know it's a path. We don't even have to walk it. We don't have to check if it's a path. All we have to do is say valid step. And then we will want to, this is where we're going to check if we are at the end. Actually, we want to do that check here. We are going to we're gonna say we're gonna define a series of points. That's how we're gonna do this. And we're gonna say that self.step oh, excuse me. We're gonna check all of the squares again. Let's make sure we did this right. This is the left, the top left, the top right, right, bottom right, bottom left. Okay. And then we're just gonna say for point in point if self.check step integrity I mean, really, we could pass these in and then split them up here, but this is fine. If the fastest route equals none, then we are going to say that the we're gonna have to keep track of our best step equals none. So if the fastest route and the best step are none, we don't need the distance. And the fastest route equals, we're not doing Manhattan distance. That's why, depending on the programming tools, is not always the best. The fastest route, we're going to say the index is going to be position to index, and then the fastest route will be self dot squares distance, and that is how we will determine what the distance is. Otherwise, we're going to say and we will just say continue if we hit that condition. Otherwise, we're going to say that if the current distance is less than the fastest route, then the new best point is the new best step is that point, and the new fastest route is that distance. And then we will return the best step. So again, we're just using the fastest route to keep track of the number, and whatever the lowest distance is, that's the step that we want to take. Maybe we need to do this here. So if we have a valid step, we just want to get the index. We want to check that distance. Okay, and then this should be good for finding our next step. So if self dot position to index of step equals the end index, we are going to say how about we do this? Step index equals self position index step, and then that way we can say if the step index is the end position, then we know that self dot walking equals false, and we're done. And or I don't know why we would ever end up with a none step in this location. We shouldn't ever hit that here. But if the self dot squares dot step index, what was I gonna check? Walked. Oh, we're already checking that here, actually. As part of valid step. Let's not check for if it's walked. We just want to see if it's mapped, which means it cannot be mapped if it was not part of a path. So we know it's a path. So we could just return mapped. But this is fine. So this will not discriminate on if the path has already been mapped and if it has already been walked. this will tell us if it's already been walked, we know that we've already reached a path that we've already walked. So we will exit early. Otherwise, we want to set the self squares. Step index walked to true. We want to set these squares step index set color to white, and then we want to set the self.step to step, and that's it. Is that the entire thing? Wonder what happens if we run this. What happens? Nothing. Missing one positional argument X. It's kind of like dereference that, I guess, is what I would call it in C. So that is not right, because I have X and Y backwards. It was close. Oh, that was not good. Oops. I think we did both of those. What did we do? I'm not even sure what happened here. No, lerp index out of range. That should not happen. T should not be greater than 1. That looked like a good map too. I don't know why this would be modulus 1. I think it should be... Because 1 is 0. I feel like that would always give you a fractional value. Right. So we're always deviating by some fractional value is what it is. What we're gonna do is we're gonna do this, or the minimum of either that or the length of blurb colors -1. I don't understand how what are we doing? We're doing this check at the wrong spot, I have a feeling. Position to index. This should stop this logic though. If we hit map and not walking, then we set walking to false. This has got to be something simple. This is supposed to be checking if we're at the end. This should hit the end. So we're not hitting this check. Why is that? Why is that? Excuse me. So why don't we check it right here? If the index equals the self int index, then we are going to say self dot walking equals false, and we're going to return, and we're going to say actually we're just going to return none. If step equals none, we're just gonna return. And we can actually say if we can assign a value to step, we can do these things. And then we can say if the position is in index or the path is walked, then we can return none. And then if we can't find the next step, then we know that we're not walking anymore. This actually looks a little bit cleaner. It kind of makes a little more sense. If we've reached the end or an already finished path, then return none. How is that invalid syntax? It's not going to let me assign a value from a function because it's inline, I bet you. Well, I guess we'll just have to do it. I bet it's because it's a class function. That's what we'll do. Still doing it. It didn't crash this time though, but why is it looking? I bet it's still looking right there too. Well, it wouldn't have let me create these points if it thought it was still looking. Valid step. Valid step if it's mapped. We do need to check if it's a path, I think. Because endpoints are not paths. That's where we're messing up. We're checking for a valid step. This doesn't need to be path because my logic was right about that. But the thing is that we're looking for a valid step here. We need to do this check outside of this integrity check because we're never going to get a valid step that is the target. The target is not a valid step because it's not a path and it hasn't been mapped. So let's see if this changes things. Well, that's not good because now we hit the path. Damn it. So we do need to check the walk in here. If self.squares IDX walked. then we want to return none also. So if we reach the end, we want to exit our walk. If we have already walked this path, we don't want to walk it again. I think that's right. So these two things have to be split up. And we want to check if we've reached the end index. And we can actually... We could actually just check the end location against the point. And then move this back inside here, because we don't ever actually need to call this calculation unless we are indexing in directly. So that's where these different types of data are useful on the outside. Let's see if that makes a difference. We're still hitting, we're doing one step. And then we check and we see oh, you know what? It's seeing the previous step. That's what it's doing. How can we do that? You know what we can do? Pathfinding. So, before we return a best step, when we find a next step, we're gonna keep walking path dot append and not idx and self.walking path. So we're going to keep a list of path steps that we've walked, and we're going to check if a walked path, if a step has been walked and that step is not in the path we are currently walking, and if we do hit the end of our walking loop, we're going to set our walking path back to none again. And then we just need to, we're going to call them walking squares. And let's try that. Still, what the hell? The struggle is real. I haven't ate anything today, so y'all are gonna have to excuse me. Well, one thing we can do is we can Or we can set that inside of there and create new start. Oh. I don't need to set these to walked or mapped. There was a bug. So when we create a new start, we want to set walking to true. And we need to set self step to none when we finish. Cool. Super cool. So I'm clicking and it's finding spots that are not in the map, and so it just fails, so I have to click it again. This is super interesting. So you can see how certain paths become more traveled than others. This is super cool. There's some bugs in it still, but I believe this is sufficient for now. This would be super cool to, like, if we got rid of the colors. If we we have a green. What if we make a dark green? Let's do half the values. And then let's go back to our color picker and pick a I want to pick like a brownish green color, like. And then what I want to do is the color will be that brown green color. It's not it's almost an olive color. And then instead of instead of interpolating the colors here, we're just gonna set the color to the dark green color. So it'll be, I want to like simulate grass and well-walked paths. So in a game, if you had towns or villages, you could pretty well determine we could almost not doing a very good job of like picking new paths. So that's kind of cool. To get here, you actually have to come this way. You could use this to generate more than just paths, but you could generate entire maps like this. That's pretty cool. Oh yeah, it's already going. It's cool seeing these paths converge. I would like to figure out what the bug is with my spawner. It's not... What if, we say, if we push the button while it's not, walking, we're gonna create a new start. And then to create a new start, I don't think this should be necessary, but it's almost like every other, I have to double click it, almost like every other click. Okay, so just for the sake of just experimenting, before we end this whole thing, I want to try a map size of like 600 by 600, like a huge map. And then we're gonna end this here. Huge map. Oh boy, this is gonna take a long time. Maybe that's a little too big. Okay, maybe we'll try like 300 by 300. Because it's exponential. That's reasonable-ish. So we won't spawn anything in this bottom third. Or in the bottom quarter even. This is super cool though. So there's our point, generating a very long path. So this could be used, I mean, and you could add layers with noise, but this could be used to generate some very cool, very large maps. And I imagine that if we weren't rendering, this would go a lot faster also. Sometimes it's hard to tell if there's a point spawned, like this point spawned. Oh wow, that's super interesting. We might think that the fastest way to go would be to just go to this path, but numerically that's actually the best way to go. And you can see here, like, sometimes it spawns paths really close to other paths, and so we don't actually like see oh, that's super interesting. I thought for sure it would tie in down here. And it could be, you could rewalk paths and add depth, or like for example, if you were using this to map density for grass, for example, you could say that these paths that get traveled more than once would have a less dense grass, and you could use the density of the grass to determine like how well speed plays in. I can't tell if it's mapping scores or not. There's definitely some bugs in my spawner. It was working perfectly fine before, so it's got to be implemented with the walking logic, but oh, and it is also spawning some like closer locations. It's hard to notice the locations that are close. But anyway, could theoretically just have it continually spawn locations. That might be something to do too. Once we hit the exit, self.spawn, create new start, and it should just continually loop these well, actually this won't work. There we go. If we turn the walking off, it won't work. And we could probably speed up the frames per second to increase the speed of this. We could use maps, more noise to create different color maps for the greens, essentially. It's super cool to see this work though. I'm glad everything came together. If anyone has any questions or anything, feel free to hit me up. Yeah, so this is just going to continually spawn paths and find new paths as long as the program runs. And maybe that's where part of the bug was. We had already walked that path and it did not end, so maybe it's walking the entire path anyway. Yeah, that's what it's doing. That's where the bug is. But I'm not going to fix it because I'm not going to use this thing beyond its current scope. I know where it's at though. But I'll leave that one to you guys. I appreciate you guys following along. If you have watched this much of it, if you guys have any requests for future ideas or any criticisms or questions, then feel free to drop it in the comments. I will check the comment. Yeah, thanks for watching. I think the next one I'm going to try to do is the 3D asteroids again. I'm going to go back and actually edit these at one point, cut out all of the confusion, but anyway, if anyone does anything cool with this, let me know, because I find this kind of stuff pretty interesting, obviously. But yeah, thanks for tuning in. Let me know if there's anything I can do to help, and I'll catch you guys on the flip. Later.